Hello everyone, myself J. Gautami from AAA section. This is my CA2 assignment of control systems. Topic name Explain the nyquist plot. Introduction to nyquist plot. A nyquist plot is a graphical representation of a system frequency response. It plots the real part of the complex function on the x-axis and the imaginary part on the y-axis. This plot is vital in control theory and signal processing for analyzing stability. Components of nyquist plot. The plot consists of a parametric curve representing complex frequency response. The frequency is varied from 0 to infinity, tracing the path of the system's response. Points on the plot indicate how the system behaves at different frequencies. Understand the axis. The x-axis represents the real part of the transfer function. The y-axis represents the imaginary part of the transfer function. Together, they provide a full view of the system's dynamic in the complex plane. Complex number A represents real part and B represents imaginary part. The formula is A plus IB. Nyquist stability criterion. The Nyquist stability criterion helps determine the stability of a closed-loop system. It involves analyzing the encirclements of the critical point -1, 0 in the plot. A stable system requires specific conditions regarding these encirclements. Interpretations of the plot. Each point on the Nyquist plot corresponds to a specific frequency of the output. The distance from the origin reflects the gain of the system at that frequency. The angle of the plot provide insight into the phase shift introduced by the system. Here you can see the charger transfer resistance and electrolyte resistance, diffusion resistance and charge transfer resistance, double layer capacitance. Application of the Nyquist plot. Nyquist plot are commonly used in control system design and analysis. Uh, they are also applied in electrical engineering for analyzing filters and amplifiers. In addition, they help in assessing the stability of various dynamic systems. Limitations of Nyquist plot. The Nyquist plot may not capture all system behaviors, particularly in nonlinear systems. It requires the system to be stable and causal for accurate interpretation. Misinterpretation of the plot can lead to incorrect conclusions about system stability. Examples of a Nyquist plot. An example Nyquist plot can illustrate a simple first-order system. This plot will show a semicircular path indicating a stable response. This visual aids in understanding how changes in parameters affect behavior. Now we can see the problem. Draw the nyquist plot for the system where open loop transfer function g of s is equals to k by s into s plus 3 and s plus 10. Determine the range of the which closed loop system is stable. Now we can see we have to find counters and poles at right side and the zeros at the right side. Step 1, we have to keep 1 plus st form in the place of given problem. We are going to substitute s is equals to jw. Uh, Here phi is equals to 19 is equals to tan inverse. There are three sections and the curves are represents s is equals to jw form. Uh, Here we can see the section 1 and section 2, section 3. The curves are going to decide the imaginary part and the real part. The planes are minus 180 and 180. 0 and 360 degrees, 240 and minus 90 degrees, and other one is 90 degrees and minus 270 degrees. SP is equals to 0 positive, and another one is negative 1. Uh, g of S is equals to k by s by 2 plus s by 1. Here we can see the answer, and it converts the g of s into h of s. Uh, Personalization, the curve will be in the stable, so stable form, it converts into the stable form. The third section is converting the curve as down to upwards, because the system is stable. uh, Personalization, uh, the personalizations are converted into peak point and the rather point. uh, After the answer is equals to w square is equals to 20, so it gives the positive, so the system is stable. Thank you. Signing off, this is G Gautami.
Signing off.